The beaches are vanishing overnight. Not eroding, not retreating, vanishing. And the reason is not what anyone is telling you. Florida has 825 miles of coastline. More than 426 of them are now classified as critically eroded by the state's own environmental agency. That is more than half. But erosion is not the real story. Erosion is what you can see. What is happening beneath the sand, beneath the seafloor, beneath the foundations of the hotels and condominiums lining the Atlantic coast, that is something else entirely. Something that no seawall can stop. Something that no renourishment project can fix. And something that is accelerating right now. In February 2026, faster than at any point in the modern measurement era. This video is going to show you exactly what is happening under Florida's feet. And by the end, you will understand why the scientists watching this data are not talking about erosion. They are talking about collapse. Here is what you need to understand first, because nothing else in this story makes sense without it. Florida does not sit on solid rock. It sits on limestone. Ancient, porous, dissolving limestone that was once the floor of a shallow tropical ocean. The entire state, every highway, every city block, every square foot of beachfront property from Miami to Jacksonville rests on a carbonate rock platform riddled with cavities, tunnels, caves, and underground voids that have been growing silently for millions of years. The process is called karstification. Slightly acidic rainwater filters down through the sand, into the rock, reacting with the calcium carbonate, dissolving it, carrying it away in solution. Year after year, decade after decade, century after century, until the void beneath the surface becomes large enough that the ceiling above it can no longer hold the weight of everything sitting on top of it. And then it collapses. This is not a theoretical risk. It is a documented, repeating reality. In 1981, a sinkhole opened beneath a residential neighborhood in Winter Park. It measured 320 feet across and 90 feet deep. It swallowed a home, a swimming pool, 6 Porsches, and the auto shop that was working on them. The crater filled with water. It is now a lake. In 2013, a sinkhole opened beneath a house in Seffner, in Hillsborough County. The hole was 30 feet wide and 20 feet deep. It opened directly beneath the bedroom of a man named Jeff Bush while he slept. The house was condemned. His body was never recovered. In 2017, a sinkhole opened in Land O Lakes just north of Tampa, 260 feet wide, and destroyed 2 homes while 5 others were evacuated. The pattern is not random. It is geological. Florida has a region geologists call Sinkhole Alley. It covers Pasco, Hernando, and Hillsborough counties north of Tampa. These 3 counties alone account for 66% of all sinkhole insurance claims filed in the state. Hernando County alone accounts for 1/4 of all sinkholes in Florida. The Spring Hill area within Hernando ranks number 1 in the nation for sinkhole frequency. 6,100. 6 sinkholes were reported in Hernando County between 2000 and 2013 alone. That is not a region becoming unstable. That is a region that has been unstable for decades and is now being watched closely enough to count the collapses. In February 2026, a sinkhole opened on Empire Church Road in Groveland, Lake County. 90 feet wide, 200 feet long, 50 feet deep. Confirmed on February 12th by geotechnical engineering firm Tierra as a direct result of limestone dissolution. The county chairman stated publicly that safety had been the priority from day one. Engineers developed a stabilization plan. Repair costs are estimated at $2.5 million. The road that 1,400 cars traveled every single day is now closed indefinitely. The Florida Geological Survey has been tracking reported subsidence incidents since 1954. Over 27,000 events on record, and the database's own documentation acknowledges that the true scale of underground instability remains unmapped. Most collapses in rural areas go unreported. Most coastal events go undetected before the ocean claims the evidence. So here is the first question you need to sit with. If the interior of Florida is collapsing at this rate, what is happening under the beaches, where the same limestone extends offshore beneath the seafloor of the Atlantic? The answer is in the data. And the data is not reassuring. You already know the ground beneath Florida is dissolving, but that process in fresh water takes centuries. What is happening along the Atlantic coast is faster, much faster, because of what is moving through the limestone right now. Saltwater. Sea levels across Florida have risen 8 inches since 1950. In the zones where acceleration has been greatest, the rise is now 1 inch every 3 years. That number sounds small, until you understand what saltwater does when it enters a karst aquifer system. It does not just flood the voids, it dissolves them. The chemistry of seawater breaks down carbonate rock significantly faster than freshwater. The voids that took centuries to form in the interior of the state are forming in decades along the coast. The Floridan aquifer system is one of the most productive aquifer systems on Earth. It stretches across the entire state, supplying fresh water to cities including Tampa, Orlando, Jacksonville, Tallahassee, and Gainesville. 92% of Florida's total population draws drinking water from groundwater, primarily from the Floridan aquifer. In 2015, Florida was withdrawing approximately 57.9 billion liters of water per day from its aquifer systems. The aquifer is not just a geological feature, it is the water supply of the entire state, and salt water is advancing through it. The South Florida Water Management District has been mapping the saltwater boundary inside the aquifer, using over 1,000 monitoring wells since 2009. The 2024 update showed results that stopped researchers mid-sentence. In the city of Davie, the saltwater interface had shifted 4 miles inland since 2019 alone. 4 miles in 5 years. In Fort Lauderdale, the inland shift exceeds 1 mile. In Hallandale Beach, the same. Chloride concentrations in monitored aquifer wells climbed from 250 milligrams per liter in the late 1990s to 600 milligrams per liter by 2024. That is a 140% increase in saltwater contamination of the limestone that forms the structural foundation beneath the coast. If what you are seeing in this video is reshaping what you thought you knew about Florida, hit subscribe and turn on the bell. Every video in this series goes deeper into the geology, the data, and the threats most people never see coming. And if you want to help others find this information, drop a like and leave a comment below telling us where you are watching from. It makes a real difference. Here is the detail that makes South Florida unlike anywhere else on Earth. The porous limestone makes building effective seawalls or levees almost impossible. The ocean does not stay on the surface. It moves through the ground, under the walls, under the streets, under the beach. The barrier you build above the waterline does not stop what is happening 10 feet below it. Miami alone projects spending at least $3.8 billion over the next 4 decades on stormwater infrastructure. That projection was built on the assumption that the ground beneath the infrastructure is stable. The ground beneath the infrastructure is limestone. The limestone is dissolving faster than the models were built to account for. There is another layer to this that the erosion reports do not mention. Sinkholes do not just create physical voids, they create chemical pathways. When a sinkhole opens, it connects the surface directly to the aquifer below, bypassing every natural filter and confining layer that normally protects the groundwater system. Agricultural runoff, road chemicals, industrial contaminants, and sewage all drain straight down into the aquifer through the sinkhole conduit. A 2016 incident at a phosphate fertilizer plant in Mulberry, Polk County made this concrete. A sinkhole opened beneath a waste stack at the facility, 300 feet deep. 215 million gallons of acidic water contaminated with phosphogypsum, sulfates, and trace radioactive elements, including radium and uranium, drained directly into the Floridan aquifer before anyone detected the event. The same aquifer that supplies drinking water to millions of residents across the state. That aquifer extends beneath Palm Beach County, beneath Broward County, beneath the barrier islands and hotel towers lining the Atlantic coast. What connects Mulberry to Deerfield Beach is not distance, it is geology. Now, here is the piece of the story that changes the entire timeline. Scientists at the University of Florida established through decades of field monitoring that sinkhole formation in Florida lags behind drought conditions by 2 to 4 years. The mechanism is precise. During drought, groundwater drops. The hydrostatic pressure that was holding the ceiling of the underground voids in place is removed. The void empties. The ceiling hangs unsupported over empty space. Then, when rainfall returns, the weight of the water above collapses the ceiling from above and the void from below. Drought followed by flood. That is the trigger. That is the sequence that has produced every major collapse event in the state's recorded geological history. Research analyzing data from 1965 to 2006 identified 3 distinct cycles. Each drought period was followed 2 to 4 years later by a peak in sinkhole collapse events. The correlation coefficient between drought periods and collapse events over that 40-year span was 0.999. That is not a trend. That is a mathematical relationship as close to certainty as geoscience produces. Florida entered extreme drought conditions in early 2026. As of February 23rd, 63 active wildfires were burning across the state. Relative humidity in the Big Bend and North Central regions dropped to 20%. The drought monitor showed expanding degradation across the northern half of the peninsula. Red flag fire weather warnings were in effect across multiple counties simultaneously. The 2 to 4 year lag points forward from this moment. The voids being emptied by drought conditions in February 2026 are the voids that will fail when the rains return. And here is the variable that amplifies everything. Farming activity in Florida requires pumping warm water underground during cold snaps to protect crops from freezing. That pumping destabilizes the groundwater table at exactly the moments when the system is already stressed by winter drought. Research confirms that sinkholes in Florida occur with disproportionate frequency in January and February, and again in May and June, precisely during these pumping periods. The current moment, late winter 2026, places Florida at the peak of both cycles simultaneously. And it does not stop at Florida's state lines. The Atlantic coastal plain, the geological formation that runs beneath the eastern seaboard from Florida through Georgia, South Carolina, and North Carolina, is built on the same carbonate rock. The United States Geological Survey has confirmed dissolution and collapse features scattered across miles of seafloor off the northeastern Florida shelf. Those features do not terminate at any state boundary. The processes running beneath the beaches of Palm Beach County are running at varying depths beneath coastal communities hundreds of miles to the north. The aquifer systems of the southeastern United States are interconnected. Pressure changes in one region propagate through the system. A collapse in one zone alters the geometry of the voids in adjacent zones. More than 3.5 million people in Florida are currently assessed as being at risk from coastal flooding. By 2050, that number grows by 1.1 million. Those projections account for what rises above the surface. They do not fully account for what is collapsing beneath it. Approximately 6,500 sinkhole insurance claims are filed in Florida every year. And insurance researchers acknowledge that represents a fraction of actual events. Most collapses in undeveloped areas, coastal zones, and offshore shelf environments go entirely unrecorded. The database of what is actually happening beneath Florida's coast does not yet exist. There is no instrument network watching Florida's coastal karst, the way deep-sea monitoring arrays watch submarine volcanoes. There is no physics-based failure model running daily updates on the cumulative strain building inside the voids beneath the beach communities of the Atlantic coast. There is no publicly archived prediction. No countdown updated in real time. No fiber optic cable on the seafloor registering every millimeter of movement in the rock below. What exists is a database of reported incidents. Most unverified, most incomplete. A shoreline survey program tracking sand levels, but not the voids beneath them. and a geological system that has been building toward a threshold for decades, accelerated now by drought, by saltwater intrusion, by sea level rise, by population growth pumping the aquifer at record rates, and by the weight of millions of people and thousands of buildings sitting on top of dissolving rock that no engineering model fully accounts for. The beaches are not just disappearing from above, they are being hollowed out from below. The sand you see on the surface is the last layer over a system that has been weakening for generations. The collapses you read about in the interior of the state are not separate events. They are signals from the same formation that extends offshore, beneath the seafloor, beneath the surf, beneath every square foot of beach that millions of tourists stand on every year without any awareness of what is shifting beneath their feet. And the question is not whether the collapse continues. The question is how far inland it reaches, how far offshore it has already progressed, and whether the science that has spent decades mapping the interior of the state will finally turn its instruments toward the coast before the coast itself provides the answer. The ground is moving. The chemistry is accelerating. The voids are there, and no one can stop it.